Well, this question is saying the statement P and negation or Q or negation P and Q is equivalent to which of these following four? Well, since this question involves only two subparts, or let's say two substatements that are P and Q, and then various combinations of this question can be solved in two different ways. Yes, one is when I'll try to solve this entire statement using some laws which we have read. Another approach is using Venn diagram. Though I love the second approach because that is sometimes very easier to crack down and finally reach to the answer. Let me explain both the approaches to you, and you on your own can decide which approach you would prefer to use. Okay, so starting with my first approach, I will here try to simplify this statement. What I'll do is, in these terms, I'll apply my distributive law. So it's going to be P or Q, and then I'll have and negation Q or Q, right? Or I have negation P and Q. Clear? So quickly simplifying the bracket term, negation Q or Q is going to give me true, isn't it? So this is true. So I'm left with P or Q and true, and then or with negation P and Q. So whenever I write T and let's say a statement S, what does it give me? It gives me always S. How? You can put some values of S if you don't remember this law. Let's say S is true. So we know that T and T is definitely going to give me T. And if my S is false, we know that T and F is going to give me F. So it is depending upon the output of S, right? So therefore, T and S is always equal to S. So this part is simplified as P or Q. Then I have or times of negation P and Q. Now again, I'm trying to use the distributive law. So my first term will become P or Q or negation of P. While my second part is going to become and P or Q or Q. Right? So coming to the first term, I have P or negation of P. P or negation of P is true. And if I take true T or Q, it's definitely going to give me T. Right? Perfect. So I'm left here with and times of what do I have in this bracket? I have P or Q, so that is going to give me P or Q only. And when I take T and with P or Q, we have just seen that it is equal to P or Q itself. So the final equivalent statement will become P or Q. Have you understood how we have simplified? You have to keep on practicing this part, guys. I know it's not, very easy to do, but when you actually practice more and more questions, this part definitely will ease out. Okay? Perfect. What I have told you, I have one more approach for you that is bit on a easier side. Let's quickly see that part also. So I have my statement this. What I'll do, I'll take my P in my Venn diagram equivalent to set A, and I'll take my Q in my Venn diagram equivalent to set B. Okay, so that means my first statement, which is P and negation Q, this and is written equivalent to intersection, while this or is written equivalent to union, according to set theory. Clear? So and is equivalent to intersection and or is equivalent to union. This you have to remember. Then what does this negation Q implies? Well, since Q is my B set, negation Q will be actually equivalent to B complement. Understood? So my first part actually becomes what? My first part becomes A intersection B complement. I hope you know how to draw this part. A intersection B complement. This will be the set A intersection B complement. Clear? What is my next part? Well, my next part is negation of P. Sorry, my next part is Q. That is my set B. So I have my set B like this. Understood? Okay. And the last one is negation P and Q. That means I have A complement intersection B. right? A complement intersection B. And you know how to plot A complement intersection B. It's going to give me this region. Now what? Now we have to take or, that means union of all these three. So when we actually take union of all these three, that means when I just combine these three parts, you can clearly see that when I combine these three shaded regions, I'm going to get nothing but the entire part, which is A union B. And when I want to write this back to my logical implications or in the logical statement form, A is nothing but my P, right? Union is nothing but or, and B is nothing but Q. So it is equivalent to P or Q. Understood? So isn't it a simple approach to solve this question? I hope you definitely agree with me. It is one of, or it is the simplest approach to solve it, right? Perfect. So the answer with us again is same, that is P or Q statement, or let's say option B. Well, the question says let P is the statement saying 2 is a prime number, Q is the statement saying cos 30 degree is 1 by 2, R is saying sec square x plus tan square x is equal to 1, S is saying root 7 is an irrational number, and U is saying pi square is greater than 10. Which among the following statements are valid? What are valid statements whose truth value is true? Right? Perfect. So they have given us the options over here. We have to find among all these four options which group actually will be the valid one. That means all the statements in that group will be true. Clear? Perfect. So let's quickly start with the question. Let's first write down the truth value of P, Q, R, S, and U. Then only we can decide on truth values of P or Q, Q or R, and further combinations. Right? Okay. So coming to the P, it's saying 2 is a prime number. Is it a true statement, guys? Well, yes, it's true because we know that 2 is the smallest prime number. Cos 30 is 1 by 2. This is my Q statement. Is it true? Well, this is false. We know cos 30 degree is root 3 by 2. Coming to the R, it's saying sec square x plus tan square x is 1, which is again false because it's minus in between, which will make the value equal to 1. And then we have root 7 is an irrational number, which will be definitely true. Pi square is greater than 10 will become false, right? Perfect. So these are the truth values available with us. Now we have to check for the options. So let's start with option A. So option A, my first part is saying P or Q. So that means I have T or F. So what is T or F, guys? Well, that is true, right? So P or Q is true. Then I have Q or R. What about Q or R? Well, I have Q as false, R again as false. So what is F or F? Well, that value is F, right? So definitely if one is false, the entire cannot be the valid statement. So that rejects A option. Quickly moving on to the B one. So B1 says first one is P or Q, which we have just seen that it will be true. Then I have Q and R. So my Q again is false, R again is false. So we know that F and F definitely will become F. And if one is false, the entire cannot be the valid statement. So this is also rejected. Simply done, right? Okay, coming on to the C1. So C1 is saying again P or Q, which we have just seen that it will be true. Then we have Q or S. Okay, so I have Q or S now. So coming to Q is false, S is true. We can say that false or true definitely is going to become true. Then I have R or S. So R or S. In R or S, I have again false or true, which we have just seen will be equal to true, right? And lastly, I have S or U. So S or U will give me what? It's going to give me T or F. And we have seen that T or F is true. So this is definitely a valid statement because all are true. So answer definitely should be C. But let's check for D also very quickly. So D, my first one is P and Q. So when I check for P and Q, my P is basically true. Q is F. So we know that T and F definitely is going to be what? F. That's correct. So this is going to be F. And if one is F, I don't have to check the further statements. It will not be a valid statement. Right? Okay, so that means my D is also rejected. And the valid statement will become C, which is the option, right? Which will be the right option. So answer will be C. Well, the question says PQR, they denote arbitrary statements. Then what is the logical equivalence of the statement P implies Q or R? They have given us four options here. Now, guys, for this question, again, I have two approaches for you. One is really very simple because of the statement which they have given to me in the question. Other is truth table. You can always go by any of the approaches. So, if I have to draw the truth table, I have to draw truth table of these four options also, right? And then only I can check which will be equivalent with the statement given in the question. Perfect. So let's start by doing the truth table approach. So I have my P, Q, and R. Let's say like this. So first of all, I'll find Q or R. So Q or R, you know that it's T or T, definitely is T. T or F is T again. F or T is T. F or F. Here it is F. Rest of these cases will give me truth table as T. Lastly, I have F or F, which is going to give me F. Okay, so this is done. Then I have P implies Q or R. This is what they have mentioned in the question. So when I have P implies Q or R, that means T implies T. Definitely will be T. Again, T implies T. Definitely will be T. T implies T. Third case will give me T. But when you have T implies F, this is the only scenario where it's going to give me F, right? Okay, then I have F implies T, which is again T. F implies T, again T. F implies T. F implies F, both will be T. Understood? So this is the truth table of the statement which they have mentioned to me in the question. Now, checking with the options. So first, let's find P or Q. So P or Q is going to give me T or T, which is T. Again, T or T is T. T or F, T or F is going to give me T in both the cases. F or T, F or T, again T. But lastly, when we have F or F, it's going to give me F. Clear? And now we'll find or we'll check the first option, that was P or Q implies R. So when I have P or Q, that is T, implies T is going to give me T. Then I have T implies F. Well, we have already seen that T implies F gives us F. Then I have T implies T giving me T. Again, T implies F is going to give me F. Then I have again the same combination, T implies T, which is T. T implies F, which is F. Then in the second last case, I have F implies T, which is T. And lastly, I have F implies F, which is going to give me T. So is it matching with my fifth column? So are these two equivalent, guys? Well, no, because they do not share the same truth values. Clear? So my first option definitely will not be correct. Moving further, I have, let's say, found out P implies Q. So P implies Q, we have already seen it's T implies T, always will give me T. When I have T implies F, it's going to give me F. Rest of the four cases will definitely give me T, right? Perfect. Then I have P implies R. So when I have P implies R, when I have T implies T, it's T. But when I have T implies F is F. Then again T implies T is T. T implies F is F. For the rest of the cases, I have F implies T, which is T. I have F implies F, which is T again. And two cases which are left again are going to give me truth value as T. Now what do we have? Now we have P implies Q or P implies R. So when I write P implies Q or P implies R, that means I have to take or in these two. So it's going to give me T, then T or F, again T. Then I have F or T, which is going to give me T, while F or F is F. Then I have T or T in all these combinations is going to give me T. Clear? Okay. And what did we just find out? I have to check it's logically equivalent with what they have given to me in the question. P implies Q or R, which truth table we have just seen. So is it coming same? Yes, bingo. These two are actually coming same, isn't it? Both the truth values are same. So definitely this will be the answer, or let's say one of the correct options. Now, checking the rest of the options also, let's quickly have P, Q, and R with us. Now I'm trying to find P implies negation Q. So when I plot or when I write the truth table of P implies negation Q, my Q is true in first case. So it's going to become true implies F. What is true implies F? Well, that value is F, isn't it? So first one is F. Again, the same scenario is going to repeat. That is F. In the third one, when my Q is F, it's going to give me T implies T. And what is T implies T? Well, that value is T, right? In the fourth one, again, the scenario will be same. I'm going to get T. Then I have Q as T. So negation will become F. So I have F implies F in sixth and fifth one. So both are going to give me T because F implies F is T, right? Then I have Q again as F and negation of that is going to become T. So I have F implies T in last two. And we know that F implies T again is T. So last two are going to give me T. Clear? Then I have P implies negation R also. So quickly we can write for that also. My R is T. So first case will have T implies F, which definitely is going to give me F. Then R is F. So negation will be T. So I have T implies T, which is definitely going to give me T. Then I have R as T. So I'll have T implies F with me, which value is actually equal to F. Then I have R as F. So I'll have T implies T, which is going to give me T, right? Then I have R as T. So it will be F implies F, which is again T. Then I have R as F. So it's F implies T. In this one, it's going to give me again T. Then I have R as T. So I have F implies F, which is going to give me T. So this one is also equal to T. And lastly, when R is F and P is also F, I'll have F implies T, which again is going to give me T. Clear? So this is my P implies negation R. Now I have to find P implies negation Q and P implies R. So P implies negation Q and P implies R. For that, quickly write down. Let's see what P implies R is. So when I have both as true, we know that true implies true is true. When I have true implies F, well, that is F. True implies true is true. True implies F is again F. F implies true is true. F implies F is again true. Then I have F implies true, again true. F implies F is again true. And now I have to take intersection of this with P implies negation Q. So first is F and T, definitely will be F. Then I have F and F, definitely again F. Then I have T and T will give me T. Then I have T and F, definitely F. Then I have T and T is going to give me T. Then I have T and T in rest of the cases, which will be T again, right? Okay, so this is what we have got truth table for this part. Then we have next one as P implies Q and P implies negation R. So quickly writing P implies Q. So my P implies Q is going to give me what? P implies Q will be true implies true, that is true. Again, true implies true, that is true. True implies false in these two cases is going to give me false. In these rest of the cases, I have either F implies true or F implies F. And both of them will be true, right? So last four are going to become true. And now I have to take its and with P implies negation R. So I have F and T, definitely F. Then I have T and T, definitely T. I have F and F and F. T and F is going to give me F again. And then I have T with T. I have to take and. So all these cases are going to give me T. Clear? Okay. Now I have to check whether of these two parts, which one is equivalent with what they have mentioned in the question, which is P implies Q or R. So none of these two are actually matching with what we have got over here, right? So that means these two are again not matching with it. So what we have got till now is that this is actually equivalent to P implies Q or P implies R. This has to be the right answer. Clear? So this is one approach by drawing the truth table. Suppose if you don't want to go by truth table, then what? Then I'll have a shorter approach for you. The approach is whenever we write P implies Q, let's say, what do you mean by this? Or let's say what can be written in place of P implies Q? You can always write it as equivalent to negation P or Q, right? So that means if I have P implies Q or R, it's going to be negation P or Q or R. And now I'll just split it. So it's going to be negation P or Q or negation P or R. And further, I'll convert this into my conditional statement. Negation P or Q is nothing but P implies Q. I have this as 1, then I have or, and then negation P or R is again written as P implies R. And which of the options do we find correct now? B, which we have just found out by truth table also. So this is an easier approach. Definitely it is very simple, right? So the answer for the question will become B. Now, coming to the question, it's saying what is the inverse of the proposition P and negation Q implies R? Okay, so first of all, what is inverse? Well, if I have P implies Q, right? If P then Q, then its inverse is actually equal to what? Can you recall? Well, if you can, let's start with the solution. So we have to find inverse of this statement. Let me say this is my P and this is my Q. So if I have P implies Q, its inverse is nothing but negation P implies negation Q, isn't it? This is the inverse. So in this case, I have to say that if I have to find inverse of this, it's going to be negation of P and negation Q implies negation R, isn't it? Now, well, now I have to simplify this first part. So we already know that if I have P and Q, suppose, what is negation of this? Well, negation of and becomes or, right? So this is going to become negation of P or negation of Q. Is this much clear? Okay, perfect. So we are going to apply the same thing over here. So the first part is going to become negation of P, then it will become or, and then I have negation of negation Q. Now what is negation of negation Q? Well, that is Q. That's right. So this is going to become Q. And we have implies negation R. So this is going to be the final inverse of the proposition which was given to us in the question. Is this clear, guys? You know now how to do it? Perfect. So now if we look at the options, we can say that answer will become B. A really simple question, just you have to remember what is inverse of P implies Q. Don't forget, what is it? Well, it's negation P implies negation Q. Clear, guys? Well, this question is a very interesting question, guys. Let's see what the question is saying. If P and negation Q and P and R implies negation P or Q is false. So if this entire statement is false, then what are the truth values of P, Q and R? So one thing which comes in our mind is we have to do this by truth table. There is no other option. But you can see that if we go to draw, or if we actually go by that step or go down by that lane, the question will become very lengthy, right? I have to plot truth table for P, then Q, then negation Q, then R, then P and negation Q, then P and R, and then the entire implication part, and then see that when it is going to be false, accordingly we'll get the truth value of P, Q and R. Zapped, right? The question actually is pretty lengthy if we go by that step or by that method. But we are not going to do it like that. This question actually is very simple. Just bear with me. What am I saying here is, if I have P implies Q, can you just recall and tell me when this becomes false? We have already seen P implies Q truth table, right? So we know that this is false only when I have P as true and Q as false. This is the only one thing which we have, that this is going to be false when I have P as true and Q as false. If you don't remember this, don't bother. I'll tell you one more method. P implies Q can be written as negation P or Q. This you know, right? Okay, so now you tell me if I have negation P or Q as false. So when does my or gives me false? Well, if we think or gives us false when both of the statements are false, isn't it? When both are false, we know false or false definitely will give me false. Okay, so that means if my negation of P is false, my P has to be true. And similarly, my Q is false. So we have reached the same condition that P has to be true and Q will be false. This is the only condition when P implies Q will become false. Is this much clear? Okay. So this much we have already learned. Now what? Well, now again we'll go by the same term. I have negation P or Q as false. So when I have negation P or Q as false, we have just seen that it becomes false when both are false, right? And if I have negation P as false, that means my P has to be true. And my Q is definitely false. So I've got truth values for two of them, P and Q. Now I have to work for truth value of R. Clear? Okay. How are we going to do this? Well, we have one more condition that P and negation Q and P and R has to be true. Now you tell me one more thing. When does and gives me true? Well, again, if we recall the truth table of and, we know that and gives us true only when both are true. Isn't it? Okay, so P and negation Q definitely will be true because P is true and negation Q is also true. So this is correct. So I have now P and R and this has to be true. Now P is true. We know that this happens only when R is also true. This is the only case which is possible. So that means I can say that my final truth table or the truth values of P, Q and R are going to become T, F and T respectively. Have you understood? No need to draw the truth table, nothing. What you have to remember here is that whenever we have P implies Q and it is actually false, it only happens when P is true and Q is false. First thing is that. Second thing is when I have P or Q as false, again it only happens when both of them are false. This is second thing, right? And the third thing which we have learned over here is that, or let's say revised over here, is that P and Q, this is true only when both of these are true. So these are the things which we have used in this question, and you can see the question or the solution part is actually pretty simple, isn't it? Have you learned a new trick over here? I hope you have done that. So now let's go to the options. We can see the options and say that answer will become B.